Welcome to the DIY Honda Garage channel. DTC P0235-62, which stands for Turbocharger Boost Sensor Circuit Range Performance, indicates that the PCM has detected an anomaly in the output values from the turbocharger boost sensor compared to the barometric and MAP manifold absolute pressure sensors. The PCM, or Powertrain Control Module, is the computer responsible for engine and transmission control, and it relies on accurate sensor data to maintain optimal engine performance. If the sensor readings do not correlate under certain driving conditions, the DTC is triggered. It is vital to understand the role of the turbocharger boost sensor. It measures the boost pressure generated by the turbocharger, which helps the PCM adjust fuel delivery and ignition timing for improved performance. This issue may affect the vehicle's acceleration and overall drivability, necessitating immediate attention. The primary component involved in DTC P0235-62 is the turbocharger boost sensor. This sensor plays a crucial role in measuring the boost pressure produced by the turbocharger, which enhances engine efficiency and power. It is typically located near the turbocharger assembly, making it accessible for inspection and testing. If the sensor output value deviates from the corresponding values of the baro sensor and MAP sensor during specific driving conditions, the PCM recognizes a potential fault. This discrepancy can trigger the DTC when the turbocharger is unable to provide the expected boost levels, leading to performance issues. Accurate readings from the turbocharger boost sensor are essential for optimal vehicle performance and emissions control. Several factors could lead to the triggering of DTC P0235-62. Firstly, a malfunction of the turbocharger boost sensor itself could cause inaccurate readings, thereby affecting performance. Electrical issues, such as poor connections, damaged wiring, or shorts in the harness, can also lead to signal disruptions. Mechanical faults, particularly in the turbocharger assembly or its internals, may prevent it from generating the expected boost, which would create discrepancies in sensor readings. Environmental factors, such as temperature changes, can also play a role in sensor performance. It is essential to conduct a thorough investigation of these potential causes to accurately diagnose the issue and ensure a reliable repair. The symptoms of DTC P0235-62 can significantly affect vehicle operation. One of the most noticeable issues is reduced engine performance, leading to sluggish acceleration and overall inefficiency. Drivers may also observe a persistent check engine light on the dashboard, indicating that the PCM has stored this trouble code. Additionally, poor acceleration can occur, especially when the vehicle is under heavy load or during rapid throttle changes. Inconsistent engine behavior may also be present, with noticeable delays in engine response. This combination of symptoms demands immediate diagnostic attention to avoid further issues affecting drivability and engine health. For the first troubleshooting step, start the engine and hold the engine speed at 3,000 RPM without any load, ensuring that the vehicle is in park or neutral. This operation allows for a stable environment to evaluate sensor readings. Continue to hold this RPM until the radiator fan engages, at which point the engine is generating adequate heat and airflow within the system. Afterward, allow the engine to idle for at least 8 seconds to stabilize readings. This process is critical as it helps in capturing accurate data regarding performance under strain and prepares the system for the next diagnostic commands. Monitoring the onboard diagnostics during this phase will provide a clearer picture to detect any abnormalities with the turbocharger boost sensor. The second step in troubleshooting involves a test drive of the vehicle for several minutes to evaluate sensor performance under real-world driving conditions. This is crucial, as sensor readings may fluctuate based on engine load, speed, and other dynamic parameters. During this test drive, it is important to monitor specific parameters through the Honda Diagnostic System HDS, including engine speed, vehicle speed, relative throttle position, REL-TP, sensor data, calculated load value, CLV, and accelerator pedal position, APP, sensor readings. After completing the drive, checking the OBD status for DTC P0235-62 or P0236 will provide insight into whether the problem persists. This comprehensive evaluation helps identify if the issue is consistently reproducible and directs further diagnostic efforts effectively. In this troubleshooting step, turn the vehicle to on mode without starting the engine. This enables the vehicle's electronic systems to power up while allowing for initial diagnostic checks. Using the HDS, confirm the TC turbocharger boost pressure and the barometric sensor readings. The normal operational condition requires that the difference between these two pressures be less than 26.7 kilopascal, which is approximately 7.9 inchi or 200 millimeters inchi. If the readings exceed this range, it suggests a problem with the turbocharger boost sensor or its functioning. Ensuring these values stay within specified limits is key for the turbocharger system to function optimally, and discrepancies must be investigated further to mitigate potential performance losses. The fourth troubleshooting step entails recording the TC boost pressure value from the data list via the HDS. Begin by starting the engine and maintaining an engine speed of 3,000 RPM without any load. This step is important because it allows the turbocharger system to operate under controlled circumstances, maximizing the likelihood of capturing accurate pressure readings. After holding this speed until the radiator fan engages, transition to idling operations. Subsequently, increase the engine speed to 4,500 RPM without load and monitor the TC boost pressure once more. For optimal performance, the TC boost pressure should read less than 0.67 kilopascal, approximately 0.2 inch Hg, or 5 millimeters of mercury. If the values recorded during this procedure fall outside the normal range, it indicates a malfunction within the turbocharger boost sensor, requiring further inspection and likely replacement to restore proper function. Once all necessary repairs have been executed, it is crucial to verify that the issues related to DTC P0235-62 are fully resolved. Begin by confirming that all repairs were completed as per the diagnostic steps outlined earlier. This involves ensuring that the turbocharger boost sensor and associated components were addressed effectively. After these checks, retest the functionality of the turbocharger boost sensor while observing the readings through the HDS. Any readings should reflect a normal operating range. Finally, clear any DTC codes using the HDS to reset the system. This process is vital to ensure that the system is functioning correctly without any lingering faults, allowing for accurate performance monitoring in subsequent driving scenarios. Preventive maintenance plays a pivotal role in avoiding issues related to the turbocharger boost sensor and overall engine performance. Regular inspections of the turbocharger boost sensor and associated wiring can help identify any potential issues before they escalate into significant problems. Checking the condition of the electrical connections often catches wear or corrosion that could lead to performance disruptions. Additionally, keeping the engine well maintained through regular oil changes, air filter replacements, and overall fluid checks contributes to optimal operation. Promoting an overall clean and functional engine environment impacts the efficiency of sensors and performance components significantly, preventing future occurrences of trouble codes like P0235-62. In summary, DTC P0235-62 signifies potential issues with the turbocharger boost sensor's performance. Understanding how this code affects vehicle performance is essential for diagnosis and repair. The troubleshooting steps outlined provide a comprehensive framework for identifying the root cause and rectifying the sensor's functionality. Through careful observation and verification, mechanics can resolve the issue effectively, ensuring the vehicle operates without any anomalies. Moreover, implementing preventive maintenance strategies is critical to prolonging the lifespan of the turbocharger system and improving overall engine efficiency. By prioritizing regular maintenance practices, vehicle owners can significantly reduce the risks of encountering the same issues in the future. Please like and subscribe to the channel. See you next time!